A very good morning to all dear students. Now in this topic we are going to discuss about different theories of paramagnetism. What are the different theories was explained by the different scientists in the advanced SSB. We are going to discuss particularly about about the origin of different type of paramagnetism and what are the different theories are there in the paramagnetism we are going to discuss. Understood? This is called the theories of paramagnetism. Paramagnetism. So, what is meant by theories of paramagnetism? Before knowing that, we should know some of the fundamental equations of the paramagnetism. We know last class we have discussed about the Lagrange's theory of paramagnetism. Based on that only, we have got the two theories now. That is nothing but about the paramagnetism is nothing but first theory about the classical theory, another is the quantum theory. I will try to explain the quantum theory also. Before knowing that, I will explain some fundamental here. Then we can go through in detail in what actually the classical theory is explained. Based on the failure of the classical theory, we got the another advanced theory that is called the quantum theory of the paramagnetism again. So in this class, we will try to bring the notice to you that how due to the failure, what failure? The failure of the paramagnetic material. Understood? Due to the failure of the paramagnetic material of classical theory, then quantum mechanical theories came to the existence. If time permits, we will try to discuss about the paramagnetic theory. First, I will try to explain about the difference. What are the difference of paramagnetic material, ferromagnetic and diamagnetic we have discussed. Let us not enter more detail about that. So the basic point we will try to explain here what actually the magnetic moment and magnetic field state equation. First equation we will try to know. Then we will go in depth. Then we can be able to understand the different theories. So we very well know what is meant by magnetic moment. Magnetic moment. A magnetic moment is also known as another word we are using magnetic moment or magnetic field strength, magnetic field. All names are same. Magnetic field or magnetic flux induction. This all terms are considered the same. And how we can define the magnetic moment, the magnetic field, or magnetic flux intensity means it is denoted by the symbol B and U into not into X. Understood? Like that, we are having the different terms to determine how actually the paramagnetic moments are going to move. Understood? Where V naught is what? V naught will define about susceptibility. Permeability, that is 4.4 into 10 power minus 7 angstrom per meter. Understood? So like this we are having the different values how to calculate the paramagnetic materials are able to known by the different. And now another is called M. That is called magnetization. Magnetization. Magnetization is defined what it is also same but little bit different. So what is the difference between that? We should know how magnetic induction is denoted by M. Actually here M is the magnetic moment M. So we'll substitute M. So M is what? That is nothing but mu into H. Understood? So magnetization will explain about the how much amount of magnetic moment or magnetic field is acting per unit area. Understood? So please try to know the difference. Then we will enter into the theories of paramagnetism. So magnetic moment or magnetic field or magnetic flux induction is also same. Any metal you could try to take up to some certain area it is going to act. That is called magnetic field mark. And here we should know that what is magnetic magnetization. Magnetization is nothing but if you want to take any magnet, how much amount of magnetic movement is acting that per area. Suppose you have taken magnet in this area, how much is acting? In this area, that how much? That is nothing but mu into L. So mu naught is equal to 4.2 10 power minus 7 meter value. That's it. Now we got first and second equation. Now substituting m value in this, what happened? We are going to get the another equation. It's called B equal to mu naught already we have. We'll substitute all these values in this. Understand? So we are going to get the new equation. What is the new equation? Let us try to know by adding the both. Not substituting directly, we are adding. Understand? Plus mu naught x. So b is equal to mu naught we have taken common m plus h. Understood? M plus h we are getting. And what is h here? H we are having the another value for the h also we are going to have. So what is that we are having? That is nothing but mu naught into m. Mu naught into m is the value we are getting. And here we are going to get what? We are going to get the value of how much amount of magnetic flux is going to act here. Understood? So now what happens again? Whatever we are having, we are wherever we are having the m value, we are going to substitute another equation. That is nothing but m equal to susceptibility lambda by h. Understood? So here we are using this equation. We can add m equal to lambda into h. What is here lambda? Is nothing but it is actually not lambda, it is susceptibility. So wherever we are having m here, we are going to substitute the equation. I hope you are able to see that clearly. And mu naught we have as it is, and we are having h plus h. Understood? So we are taking not only the mu term common. Not only the mu term is taken to the common, along with the mu term we are taking the another term common, that is h. So 1 plus, we are getting 1 h plus h. Understood? Like that we are going to get the actual value for the equation. And overall, whatever we are having here, the equation we are going to get, it is equal to what? It is nothing but mu r. Understood? So b is equal to I will write here better to understand. B is equal to whatever equation what mu into h 1 plus susceptibility. So again another equation for b or b. I am taking h is common. Mu naught equal to 1 plus susceptibility into h separately. So what will happen now? B is equal to this whole equation is equal to mu naught h mu r. Understood? Susceptibility of any material. If we are moving from one material to the another material, is nothing but the mu naught value. So like that we are getting mu naught 1 plus h. H is the constant value we are going to get. Like that we are able to calculate how much amount of flux density is going to change from the one material to another material. Now the advanced theory, in order to explain more detailedly what we require the more assumption theories are required. Otherwise we cannot able to understand. So overall what we are understanding, we are able to understand how the theories of paramagnetism are going to emerge now. Now let us discuss classically what are the limitations are there in this theory also we will try to discuss now. So now we will discuss about the magnetic field, magnetic induction, magnetic flux up to what area it is having. B equal to mu naught h, B equal to mu naught m. Like that addition of all that we have got the how much amount of magnetization is acting wherein. Now what is the origin of what are the theories of paramagnetism? First of all, I will try to explain some summary here. Then I will try to explain it detailing one by one here. So the basic theory of paramagnetism is divided into two categories. The first category is which we have discussed in the classical theory, and little bit theory is there. We will try to explain. Here basically what happened, any material that is called the paramagnetic material if you are taking, definitely what happened, there is a whatever the materials, the dipoles which are present, already the dipoles are present inside any magnetic material. Understood? Dipoles we very well know because in introduction class we have discussed two north pole and south pole. So the alignment of the dipoles are along the direction. How much compared to ferromagnetic? Paramagnetics are less and diamagnetics are opposite. The alignment is opposite. But here what happened? Paramagnetic material, the alignment of molecules, whatever we are having, they are trying to move. Not acts compared to the ferromagnetic. If you ferromagnetic will taken just iron and bring the magnet before it did, what will happen? Definitely it will try to attract you immediately. Understood? And whereas these paramagnetic materials are what, they are having a less dipole numbers, less dipole numbers. Where due to the less number of dipole moments are coming, what will happen? It will try to attract some of the atom. So how it is happening? What is the origin of the paramagnetism is what we are going to discuss. Here we are having some thermal agitation concept is there, and different type of forms of energies are there. Let us we will try to see here by detailing what are the fundamental things are going to happen in the theories of paramagnetism. And we are having the two categories currently. And here the classical theory of paramagnetism developed by whom? Leibniz. It was developed by the scientist that is called Leibniz. Leibniz theory. I will explain the theoretical part. It was developed by the scientist Leibniz. And the classical is called the classical theory of paramagnetism. Understood? Developed by Leibniz considered paramagnetic in the solid in terms of glass. Understood? He considered the paramagnetic materials. Paramagnetic material as gas. As gas. He considered what he taken a material that is called the paramagnetic material, and this paramagnetic material again he what he have done, he considered that material as a gas. Now what happened? Let us first task is what we have taken the Leibniz theory and how the Leibniz theory is taken a paramagnetic material as it is considered a gas. Now another task what we are having, another task of this nothing but it is placed in the magnetic. So before that it is a material, but it is considered as a gas. Why we consider it gas? Why? Because according to the Maxwell-Boltzmann distribution law, we are having in statistical mechanics in first year and second year, first and second sem we have discussed. In that what I mean statistical mechanics, how Maxwell-Boltzmann distribution law, here applying Maxwell, and it is considered gas. So the number of motion of molecules can easily try to interact with each other. Understood? That's why we are considered as what we are considering here. The material paramagnetic is a gas such that it can try to interact all the molecules. Whatever the solid state physics, whatever the small arrangement lattices are there, it can easily penetrate. Now, after considering it a gas, not as a material, now keeping it in external magnetic field. External magnetic field. So what happened? We have taken one material. Of what material we have taken? Of material that is nothing but paramagnetic material. If we are taking paramagnetic material and keeping here what happened? Generally, the property of paramagnetic material is what? It will try to align whatever the number of alignment are there. Dipoles are like here, dipole is there and another dipole. Like that, feeble, not more, but feeble paramagnetic magnetic moment will be present in this material. Whereas ferromagnetic we are having a lot. So what happened? Some sort of lines are going and other lines are going away from the center of the. Understood? So like this, the key point, the Leibniz is trying to explain here key point. Now we are entering into the key and basic point. What is the key and basic point here? When the magnetic field is applied, each particle is possess a permanent magnetic field. And each when we are applying, and each particle has permanent magnetic moment. Permanent magnetic moment. We know permanent magnetic moment B equal to mu into H or mu naught into H as the permittivity of the material we can take into the consideration. So what is happening by here? We are able to see that how the materials are going to change from one frame to the another frame. So now our task is what here? The task of the material particle is a permanent magnetic moment. Now, when we are applying each particle assumed to be where a permanent magnetic material mu, when gas is placed in the magnetic field, it tends to orient itself in the magnetic axis. Now, what happened? I am taking a gas. Any material taken when we are trying to apply. What happened when we taken the material here And applying what happened, whatever the dipoles, whatever the dipoles we are going to present here, what happened, we are going to get inside some gas inside. Another is, so it is taken, how it is taken in the direction of parallel. Wherever the magnetic field is present, magnetic field is parallel to the applied gas. Applied gas. Means what I am trying to tell here, the classical theory, whatever the magnetic material we are present here and here, when we are start applying the magnetic field, external magnetic field I am trying to apply parallel to it, what happens? They are moving along the gas. Means I will try to explain detailing here. When magnetic material is like this, the orientation of magnetic movement is take along parallel. If lines are moving in this direction, the magnetic movement, whatever the magnetic movement is there inside, they are also moving. Nothing but the poles. Let us draw the diagram. Suppose we are having the poles like this. I am applying magnetic field means they are also going. Some of the majority of the poles are moving along the direction, and while moving in this direction, what is happening? While moving in this direction, a inclination a inclination of a line is going to form. What is that inclination, sir? We will try to draw here, then we can able to understand what actually this theories of paramagnetism is here. Understand? I will try to draw the diagram here. You please try to watch it. Making some angle of inclination. Understand? O is the origin. Actually, we should get this line. We should get this line. But here what happened? We are getting it till alignment of angle is going to take place. Understood? From the origin. Here we are getting angle and d theta we are going to get. So alignment of angle is going to take place due to the applied magnetic field, is nothing but the H intensity of magnetization M, and here magnetic induction H magnetic field also they take. So what is happening here? So whatever the line before that, the parallel is taken, but when we are applying the external magnetic field, little bit the tilt of angle will be take place. So the distance between the 2 points, the distance between the 2 points, we are going to get some gap is going to occur. So that gap is called what we cannot call as a gap. It's called the alignment. So the alignment of the angle is going to take place in the paramagnetic material. Understood? So let us consider the unit volume of magnetic movement of material, and they are moving in the what direction? That is moving the opposite of minus mu x positive. So then what happens? We are going to get the material. How it is going to change from one direction to the another direction. So this is happening due to the what? Due to happening in the thermal equilibrium. Thermal equilibrium. Thermal equilibrium is a very important. Why it is considered thermal equilibrium? Whenever we are taking the material, when we are applying the external magnetic field, inside the material the heat energy is generated. That is called the thermal equilibrium. Before thermal equilibrium, there will be a thermal agitations. What are thermal agitations? Whenever we are taking the magnetic field or paramagnetic material, I am applying the external magnetic field like this here we have drawn. External magnetic field. Some of the dipoles which are present, they are trying to oppose and they are moving the opposite. Those having the same pole, the magnetic can go in the parallel. In this connection, what happens? There will be thermal agitations are going to generate. Understood? And this thermal generation is going to generate. That is called thermal agitation. Why it is generating? Because we are applying external magnetic field. Due to that magnet, the atoms are start vibrating. After certain interval of time, what happened? This will come to the thermal equilibrium position. Thermal equilibrium. But before coming to thermal equilibrium, the discussion what we are discussing in between the thermal agitation and thermal equilibrium, in that we are going to have, means we can tell before the graph is coming to the thermal equilibrium, after thermal agitation, in between that what happens? Slight inclination, alignment of the molecules will take place. That has explained by the theories of paramagnetism by the Lagrangians. Understood? It was explained very nicely. But these theories have some limitations also. It does not able to explain. It does not able to explain when we are applying external magnetic field, and avoidment does not satisfy permanent magnet proportional to angular momentum, and is not applicable to the when we are having the permanent magnetic moment is directly proportional to the angular moment, then it is not applicable at all. So we should apply all this equation when we are having the angular moment, then it is going to change. That is the one failure is there. Another failure is what we are having. It does not able to explain very concretely when applied to other only zero or spin. If you are having the zero or spin parallel or spin cancel, then only it is going to happen. If you are having minus infinity to plus infinity in between, then what happens? You are not able to get the exact number of what paramagnetic material spin does not able to exist. So like that we are having at the some problematic here. So here the failure, whatever the cancellation of spin, whatever we are having, addition of spin, we are not able to generate. What we are not able to generate, that is nothing but the Lagrangian theory, classical theory. So classical theory of Lagrangians are only permitted of zero spin or parallel spin of zero. We can call Lagrange's theory or theories of paramagnetism of classical theory are applicable only for the zero or spin when cancelled. Spin cancel also will become zero. So it is permanent. But when we are having the value of minus infinity to plus infinity, whatever the values plus 2, minus 2, minus 1, minus 1.2, we are not able to get these exact values. So in order to overcome these difficulties, we have developed another theory. The theory name is called the quantum theory of paramagnetism. In next class, we will try to discuss how we can able to discuss the quantum theory of paramagnetism. It is a very advanced theory. So overall in this today class, what we have discussed, we have discussed about the what is meant by magnetic field, magnetic intensity are same. Understood? B equal to mu naught H is the value we are going to generate. And what is the magnetic intensity? Magnetic intensity is nothing but the area, up to what area we are going to generate what? We are going to generate magnetic field movement, or magnetic movement is acting paired volume. That is called magnetic intensity, or intensity of magnetization is called. So next, what are the failure? How the tilting of angle is taking place due to the thermal agitations of the molecules inside the paramagnetic materials. So this is all about our today class. This is the origin point, magnetic field, how the tilt of angle is going to take place at a different direction. So it is taking a parallel direction. Again, if you are coming to the equilibrium position, please note that it will come to the same. Only theta, not d theta. The solid angle is not going to generate this equations. So like that, in this class we have discussed the definition for the magnetic moment, magnetic field or magnetic field intensity is same, and magnetization we are able to discuss. And difference, how we are going to discuss B equal to mu naught H. Again B equal to mu naught H plus mu naught M. And what is M? M is nothing but lambda into H. Substituting, we are going to generate the actual magnetic field for the material can be going to generate. Understood? Next we have discussed what are the different concepts of the paramagnetism of the theories. Next class we will discuss another theory of paramagnetism of quantum. Thank you. So now we will try to discuss a little bit about the quantum theory. What quantum theory is try to explain. In the extension part I will try to explain more detailing. Just now we have discussed about what actually does it mean, what that is classical. And there is quantum theory completely different. Quantum theory of paramagnetism. And before coming to this, we should know the failures of classical theory. Then we can come to the point. So what are the failures? Failures lead to quantum mechanics. First failure is that paramagnetic metal is only applicable for zero or anti-spins. Spins are like this and like this only cancel each other, then only it can do. So when the applicable part, that is nothing but zero, or any particle which we are having the spin is zero, that is considered as what? It is considered as is nothing but it's called the theory of paramagnetism. We are going to have that is zero or anti-spin, means two opposite spins which when we are having, then only the classical theory is happening. When we are having the spins or values between what? Between minus infinity to plus infinity. Then what happens? We are not able to applicable the theory. That theory is what called the theory for the classical theory is only applicable. And here there is a lot of confusions are added. So if a above equation does not satisfy, that is nothing but what they got the value at last, that is lambda equal to understood m by h. Susceptibility is not lambda actually, susceptibility. Difference with lambda symbol like that and susceptibility little bit more will be there, like that difference will be. Susceptibility. Understood? Like that we are having another equation. Due to that we are going to generate the equation. So we got what lambda equal to or susceptibility equal to m by h, that is mu square n by 3kb by t, where kb is nothing but Boltzmann constant according to the what? According to the Maxwell-Boltzmann statistics we are going. So proportional to the angular momentum. It is only when it is proportional to angular momentum will come when it is proportional to the angular momentum, then it is not applicable. Their laws are not at all applicable here. Understood? So again, we required what? Another theory is required. This proportional to the angular momentum is not at all possible here due to the failure. Understood? So when we are considering that number of magnetic magnets are directly or inversely proportional, then it is not at all possible to study. Understood? That is a very important aspect. This is nothing but a failure. It is not able to explain this concept also. Another thing also that does not able to explain, that is not applied to other zero spin cancel each other values. To explain the theory called quantum is required. Understood? And above equation does not satisfy the method permanent magnetic moment proportional to the angular momentum. So it is does not applicable to permanent magnetic moment. Permanent magnetic moment of atom having angular moment. Please note down angular moment. What is angular momentum? Angular momentum is nothing but any axis having spin, orbital, and another spin also considered. Last class we discussed what is the difference between the spin motion and orbital motion, origin of permanent magnetic moment or origin of magnetic momentum. In that we have discussed that is three conditions. That is the spin, origin of the permanent magnetic moment is dependent on the three conditions. That is the spin of the electron, orbital motion of the electron, and third is the nucleus spin also taken into the consideration. That is nothing but the intrinsic property of the magnet. Like that, the three applicable, but here two can be applied according to the classical. But the quantum mechanics able to explain very in depthly. Understood? In depthly is what means in minutely, micro detailly we can able to study what are the changes are going to take place inside even the intrinsic. Intrinsic means which are hidden internally, which we are unable to determine what is going to happen inside any material. That is nothing but what? That is the actual facts of the quantum mechanics. So in detail we will try to discuss in the next class what actually the quantum mechanics and deal with permanent magnetic moment or permanent magnetism. How to understand it can be also known. Like that we can able to understand what are the different concept of the permanent magnetism. So definitely we should take consideration what ma, definitely we should take the failures whatever depending on the failures, but doesn't call a failure. Whatever the available conditions are there, depending on that we are able to develop origin of permanent magnetic moment. Understood? So that is theories of permanent paramagnetism. Understood? So it is a very, and the important point is here we have discussed that is thermal agitations are there and inclination of angle is going to take place in how and what manner we are going to get different type of inclination. Understood? This inclination are due to the agitations of permanent magnetic moments, whatever we are having. The dipoles, whatever the dipoles we have generated, these dipoles are creating some problem inside the moment, and we are going to get the different type of formations of waves we are going to take and the inclination. So overall in this class we have discussed about the total about the theories of paramagnetism and how the quantum theory of paramagnetism are came into the existence. But quantum theory came. Now we are not to discuss. We will discuss in the next class what actually the quantum theory is going to explain. Understood? Thank you. We will meet in the next class.